Good morning. It's May 16th, and this is your daily brief in science. Here's everything you need to know. In a groundbreaking discovery, a recent study published in Nature reveals that the summer of 2023 has shattered temperature records, marking it as the warmest in over 2 millennia. This finding not only surpasses the critical 2 degrees Celsius threshold outlined in the Paris Agreement, but also suggests that we might be living through the hottest year in approximately 125,000 years. Researchers utilized tree ring data from the Northern Hemisphere to reconstruct this extensive climate history, offering a stark representation of our current climate trajectory. However, this revelation comes with a caveat. The absence of tree ring data from the Southern Hemisphere and the tropics means these findings cannot be universally applied, highlighting a gap in our global climate understanding. Despite this limitation, the study's lead author has voiced deep concern over the potential for irreversible climate processes and the dire implications for future generations. This sense of urgency underscores the critical need to address climate change more aggressively. The study further reinforces the importance of limiting greenhouse gas emissions, as global temperatures have not only reached but exceeded the 1.5 degrees Celsius goal set by the 2015 Paris Agreement. The researchers also caution about the ongoing influence of El Niño, which could extend into 2024, potentially breaking last year's temperature records. This insight is vital for refining projections of future climate extremes and emphasizes the immediate need for global action to mitigate the impacts of climate change. The recent solar flare on May 14, 2024, marked a significant moment in our ongoing observation of the sun's activity, being the largest event of its kind in nearly 2 decades. This flare is a part of the sun's natural 11-year cycle, a rhythm that dictates the ebb and flow of solar phenomena. The source of this remarkable event was sunspot group AR3664, a colossal area on the sun's surface, over 15 times wider than Earth. Before rotating out of view, this sunspot produced 2 potent X-class solar flares, the most recent being an X3.4 and an X2.9, leading to coronal mass ejections that reached Earth. These ejections not only enhanced aurorae, creating stunning visual displays in the sky, but also caused radio blackouts, demonstrating the tangible effects solar activity can have on our planet. The economic implications of such solar storms are staggering, with potential costs reaching up to $2.6 trillion for a severe event. The X8.7 flare, the strongest since 2005, signals that the sun is approaching the peak of its current cycle. Over the weekend, Earth witnessed the largest solar storm in over a decade, a testament to the power and unpredictability of our star. The ESA/NASA Solar and Heliospheric Observatory, SOHO, captured this and other solar outbursts on camera, providing invaluable data and breathtaking visuals of the event, including appearances by Jupiter and Venus. Despite sunspot AR3664 rotating away from Earth, its potential visibility in 2 weeks with possibly decreased activity keeps the scientific community and enthusiasts alike in anticipation. The importance of continuous monitoring of solar activity cannot be overstated, as it equips us to better understand and prepare for the impacts of these celestial phenomena on our world. In the vast expanse of our universe, astronomers have stumbled upon a discovery that turns heads and challenges conventions. Meet WASP-193b, a newly discovered exoplanet that's rewriting the rules of planetary science. Located 1,232 light-years away, this fluffy oddball stands out not just for its distance, but for its astonishing physical characteristics. WASP-193b is about 50% larger than Jupiter, yet astonishingly, it's roughly 7 times less massive. This gives it an exceptionally low density, akin to that of cotton candy, making it one of the lightest exoplanets discovered to date. Its composition, primarily of hydrogen and helium, further contributes to its unusual nature. This groundbreaking discovery has left researchers scratching their heads as it challenges existing models of planetary formation and composition. In an effort to unravel the mysteries of WASP-193b, an international team of astronomers plans to harness the capabilities of the James Webb Space Telescope. They aim to delve deeper into the planet's atmosphere, seeking insights that could shed light on its formation and characteristics. This finding not only adds a new member to the cosmic family, but also underscores the incredible diversity of planetary compositions and characteristics across the universe. In a groundbreaking study that traces the journey of one of the Earth's most iconic trees, scientists have unlocked the ancient origins and evolutionary adaptations of the baobab. This revelation not only tells us about the past, but also signals a critical path forward for conservation. Originating in Madagascar 41 million years ago, the baobab tree embarked on an incredible journey, spreading its branches to Australia and mainland Africa. This fascinating dispersal pattern was unveiled through the collaborative efforts of an international research team led by the dynamic duo of Dr. Ilya Leach and Professor Andrew Leach. Their work, recently published in Nature, involved meticulous analysis of genomes from 8 different baobab species. This deep dive into the genetic makeup of baobabs revealed how these trees evolved distinct flower structures to attract a variety of pollinators, a key survival strategy over millions of years. The study goes beyond just the evolutionary history of baobabs. It highlights how climate change has been a significant force, shaping the distribution and speciation of these trees throughout the ages. This insight is crucial, as it brings to light the urgent need for targeted conservation efforts. Baobabs are not just remarkable for their size and longevity, they hold immense cultural and ecological importance. However, they face the looming threats of climate change and deforestation, which could push them towards extinction. The researchers' findings offer essential guidance for conservation strategies, aiming to safeguard the future of these majestic trees. In the face of environmental challenges, this study underscores the importance of understanding our past to protect our future, particularly for species as culturally and ecologically significant as the baobab. Astronomers have made a groundbreaking discovery, finding an Earth-size exoplanet, SPECULOOS-3b, orbiting a red dwarf star just 55 light-years away. This discovery not only expands our understanding of the cosmos, but also marks a significant milestone in the search for exoplanets around the most common type of star in our galaxy. SPECULOOS-3b was identified by the SPECULOOS project, an initiative dedicated to detecting rocky exoplanets around nearby ultra-cool stars. This discovery is notably only the second time a planetary system has been found orbiting a red dwarf, with the first being the TRAPPIST-1 system. Despite its Earth-like size, SPECULOOS-3b presents an extreme environment, with a year lasting a mere 17 hours and the planet likely being tidally locked to its star. Red dwarfs, which make up 70% of the Milky Way's stars, are known for their long lifetimes, sparking interest in their potential to host habitable planets. However, the high radiation levels from its star render SPECULOOS-3b inhospitable. This doesn't diminish the importance of the discovery, as it provides an ideal target for the James Webb Space Telescope to investigate whether planets in close orbits can retain an atmosphere. Published in Nature Astronomy on May 15, 2024, the research surrounding SPECULOOS-3b not only advances our knowledge of planetary characteristics in extreme environments, but also opens new avenues for understanding the habitability and surface conditions of exoplanets orbiting red dwarf stars. Despite the low likelihood of an atmosphere due to intense radiation, this discovery is a step forward in our quest to understand the universe and the diverse worlds it harbors. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.